So 1.7 is what we're continuing today. Remember, 1.7 is called inequalities. So that's what our focus is going to be. And today we're going to review how to solve inequalities with absolute value. Okay, which is something that you did in Algebra 2. Okay, so we're going to solve inequalities with the absolute value. I'm just going to abbreviate that. And then we are also going to solve real world problems like we did today. I'm just going to say probs with inequalities. Okay, so it's all inequality based. And your warm up today was an equation. And then our lesson today is going to have inequality. So less than, greater than. All right, so these properties are what are used to solve inequalities with absolute value. You are going to have to know this for your assessment, but there are lots of patterns here to make it simple to remember. So if you have a less than or a less than equal to, you only have one equation. And that's because what is happening can happen at the same time. They're connected with an and. So for both of the less than situations, they're connected with an and, which means you are only going to have one inequality. It's because of these two things can happen at the same time. A value can be less than a number and then greater than the opposite of that number, right? So if C was 8, a number can be less than 8 and also greater than -8 at the same time. When you have greater than, you have an or that connects them. So for the greater than, you're going to have the or, and you have two inequalities. Okay, and that's because these situations do not occur at the same time. Okay, so for 3 and 4, these conditions cannot occur at the same time. Okay, so you can't have a value that is greater than 8, but is also less than -8, which is why we connect them with an or. They cannot happen at the same time. You also don't have to write the inequality like this. I think it's easier to remember that this is x is greater than c. So x is less than the opposite c, or x is greater than c. X is less than or equal to -c, the opposite of c, or x is greater than or equal to c. I think it's easier to remember like that. You can set it up either way. Okay, and then we just have to remember that if you have a less than or a greater than situation, when you're going to graph those, you're going to have open circles. And if you have an equal to situation, that's when they're going to be closed. Okay, I believe that's something we have memorized by now, so you just need to double check that when you are doing these on your own. Okay, so example 1, we are going to solve that absolute value inequality. And then it says that we need to express the answer using interval notation. And we're going to graph the solution set. And we're going to graph that on a number line. All right, so our first inequality is the absolute value of x minus 9 is less than 8. I honestly feel like some of the absolute values in your Algebra 2 textbook were more difficult than the ones you're going to see here. Okay, so we just have to remember how to write that in the equivalent form. So if it's the less than 8, you can always just start by doing the x minus 9 less than 8. And then you ask yourself, okay, can something be less than 8 and greater than negative 8 at the same time? Yeah, what are some numbers that are less than 8 but greater than negative 8? 0. What else? 1. What else? Negative 2, right? There's many numbers that are going to fit that. Do we remember how to solve when you have 3 sides? What if you just have this? What would you do? Yep, you just add 9. Okay, and the only difference is now we add 9 to this side as well. Okay, so each side gets the plus 9. Okay, so you have 1 is less than x, which is less than 17. All you want to do is get your x value by itself. So once you have that, you can do your interval and then your graph. Some of you might want to do your graph first and then your interval. It's honestly up to you. From 1 to 17, because it's less than, we're going to have parentheses. If it was equal to, you would have brackets. And then, like I said, you only need to label your key values. I'm putting those farther apart since there are so many numbers in between. And then I have an open circle at 1, an open circle at 17, and your x values are in between that. And again, if you want to do the graph first, sometimes I think that's helpful from going there to your interval. All right, and then for B, we have 1/3 is the absolute value of 5x plus 4 is greater than or equal to 2. Okay, so this one's a little bit different because you have a value on the outside of the absolute value. So before you can write the equivalent form, you need to isolate the absolute value first. Okay, so if we want to get the absolute value by itself, what should we do to both sides? Multiply by 3. Yep, you can divide by 1/3, or you can multiply by 3. When you are multiplying by an absolute value, because these are all multiplied together, those will just cancel. You'll have 5x plus 4 inside the absolute value is greater than or equal to 6. Okay, now you can write in the equivalent form. Okay, so I can't have something that's greater than or equal to 6 and less than or equal to -6 at the same time. So this is when you have to set up your two equations. So it's either 5x plus 4 is greater than or equal to 6, or 5x plus 4 is less than or equal to -6. Okay, so you can't just tack the less than on there because they can't happen at the same time. So we do have to separate that. Okay, so go ahead and solve those for x if you haven't already. So we're going to get x by itself. Okay, so we're going to move over the 4, so we're going to subtract that from both sides to get 5x is greater than or equal to 2. Divide by 5, x is greater than or equal to 2/5, or when we subtract 4 here, we're going to get -10. Divide by 5, x is less than or equal to -2. You don't have to flip the sign because you're dividing by a positive. It's the positive you're dividing by. Okay, so this is your solution. Again, I would suggest doing your graph first. So you have to make sure you put them in the right order. So -2 would go first, then your 2/5. So if x is greater than or equal to 2/5, I have a closed circle, and it includes all the values to the right. At -2, I have a closed circle. It's all the values to the left. Okay, so then the way I would write this in interval notation is -infinity to -2. I need to use a bracket. And anytime you have an or, you're going to have a union in your interval notation. So in union with 2/5 to infinity. Okay, and then once you get that written down, I want you to read over the story problem, and I want you to come up with an expression for plan A and an expression for plan B. Okay, so a Carnival has 2 ticket plans, Plan A and Plan B. They both have an entrance fee. Okay, so one of them it's $7 to get in, the other one it's $3 to get in. And then you have 50 cents per ride or 75 cents per ride. And it looks like we did a nice job when I was walking around and checking the purchasing or writing your expression for purchasing those. Does anybody want to share what expression they came up with? Yeah. Uh-huh. Great. And then we'll just follow that same thing here. So 3 plus, and you can put the 0 or just the 0.75. Either is fine. And then you can also just put the x term first. So either one of those is fine. Okay? What we're trying to find is how many rides would you have to take for plan A to be less expensive than plan B? Okay, and you want it to be less expensive, so it's not going to be equal to, because then it wouldn't matter, right? So if you want plan A to be less than plan B, all we're going to do is substitute in our expressions, and then we're going to solve. Okay, so for plan A, like I said, you could write it as 0.5x plus 7 if you wanted. 0.75x plus 3. And then we're getting everything on one side. We are going to do this without a calculator. So I would subtract the 0.5 from both sides. If you're having trouble with some of the decimals, you can think of it as money, right? If you have 75 cents minus 50 cents, how many cents would you have? 75 cents minus 50 cents, how many? 25 cents would be left, so 0.25. Okay, now once you get here to the 4 is less than 0.25x, I don't want to divide by a decimal, so we're going to start thinking of these in terms of fractions. So 0.25 is the same thing as 1/4. Okay, so to do this without a calculator, we're going to convert to a fraction. And if it's like something you don't know off the top of your head, you can always use the decimal place. So like the 5 is in what place? Tens, hundreds, thousands. It's in the hundreds place. So whatever you have, you can just reduce. 25 over 100, that you can divide them both by 5 or both by 25 to get 1/4. Okay, and I'm just showing you that because they might not all be fractions that you'll convert like that. Okay, and then that makes it easy for us to multiply by the reciprocal so that when you multiply, you have 16 is less than x, okay? Or you can think of it as x is greater than 16. And then we're going to write the solution in context of the problem. Okay, so if you plan to go on more than 16 rides, plan A is less expensive. Or you could say cheaper. I just said less expensive because that is what they asked in the question. Okay, and then also a note to help you with your homework, just a reminder, if you divide by a negative, or if you multiply by a negative, the sign flips. Okay, so we do need to remember that rule. That's a good reminder. That's something that's simple that we forget sometimes. All right, and example 3, it says on an extremely hot summer day, the temperature peaks at 40 degrees Celsius during the afternoon, but cools down to 5 degrees Celsius at night. To what range of temperatures does this correspond on the Fahrenheit scale? And then they give you the relationship between Celsius and Fahrenheit here. So we're going to use this as we're solving. Okay, and we want to know how to solve inequalities, so that's the strategy that we're going to use for this. Okay, so it peaks at 40 degrees Celsius and it cools down to 5 degrees Celsius. When you're thinking of temperature, if it says that it peaks at 40 degrees, does it include that? Yes. Okay, so in terms of degrees Celsius, right, it's going to go 40 degrees and yes, thank you, bye. And then down with the 5 degrees. Okay, so what we're going to do is we are going to just substitute in for C the equation, and we are going to solve this for F. Okay, and I just want you to think about what your first step could be. There are multiple ways to do this. So I want you to think about what that first step could be. Okay, so what's one way that you could do this, that you could simplify? So we're trying to solve for F. So what's one thing we could do here? Yeah, distribute, or are you going to say distribute too? Yeah, okay, so you can distribute or divide by. Yeah, and instead of dividing, I would just, I'd multiply by the reciprocal. I think that's going to be easier because we are going to be doing this without a calculator. So one thing you could do is distribute 5 ninths times F, 5 ninths times negative 32. You have to multiply by 5 and then divide, and then you have to add to both sides, and then you have to multiply by the reciprocal again. It is going to be quicker if right off the bat you multiply. Hi. Yep. What was the first name? Oh, okay, down the housing office. Okay, yep, fine. Okay, and then so we're gonna multiply each side by 9/5 first. So can you guys do that without your calculator? Okay, so when you are doing that here, those are going to cancel and you just get f minus 32 in the center. Because when you're multiplying, you don't distribute the multiplication. You're just going to multiply 5 9ths by 9/5. Those will cancel. Okay, here, when you're doing 5 times 9/5, the 5s will cancel. So that's just going to be a 9. And then when you're multiplying this by 40, right, you can still divide here. 40 divided by 5 is 8. So then from there, we're just going to do 8 times 9. Am I going too fast? I felt like I was talking a lot really quickly. Okay, and then our last step is going to be to add 32 to each side. Hello? Yes, they just called her down, so she should be there in a moment. Okay, bye. Okay, and then here we got 104. So this is going to be the 41 degrees. Oh, I'm not popular. The students are popular, right? Other people are popular, but I'm being called down for that. Okay, and then we are going to just write what this means in context. Can you guys think of any place in the U.S. that might have this range? Yeah, that's what I was thinking. That's what our other class said. Yeah. Have you been to the Grand Canyon? No. Oh. So what made you think Arizona? Yeah. Yes. So any place that has like a desert in it or like in the canyons, they get really cold. Did you guys know it snows at the Grand Canyon? Yeah, see, I for my 40th birthday, I was like, oh, I want to go somewhere I've never been. So I was like, oh, I'll go to the Grand Canyon. And it snowed, like we looked it up before we went, and I was like, what? We went for our spring break, so like the end of March. Yeah. And then went to the Grand Canyon and then further south and then there, it was in the 80s. It wasn't quite 100, but in the summer, I believe it could happen. All right, so for your assignment, your 1.7, okay, you guys have 30 minutes to work on this. So you need to turn in 30 minutes of work into Google Classroom. Okay, if you would like the full points for it, you do need to attempt every question. If you would like to not receive a 0, you have to work on this in class. Okay, and then if you can't finish it outside of class, as long as you turn in your 30 minutes of work inside of class, I'll make it a no count for you. Okay, I'm going to show you that on the assignment too.